Last day we studied about relative atomic mass and relative molecular mass and how to calculate that. Today our lesson is the mole. Mole is the unit to measure the number of particles in a particular matter. It indicates a number 6 into 6.022 into 10 to the power 23. So this is very similar to the day-to-day life word, the dozen. You know that dozen means anything, 12 of things. As an example, 12 books. Dozen means 12. 12 books can be called a dozen of books. 12 elephants can be called a dozen of elephants. Whatever the object is, it doesn't matter. It indicates 12. It's like that one mole indicates this number of things. It's a very huge number, a large number, which is known as the Avogadro constant also. So that dozen is used to measure the day-to-day things, but the mole is not like that. There's no meaning. If the mole is used to measure larger objects, it doesn't give any meaning because this is a very large number. As an example, if you say that one mole of people, it doesn't give a meaning. It has a meaning, but the one mole of people is not there on the earth even. We know world population is nearly 8 billion. So that we can write it like this: 8 into 10 to the power 9. So that if this number of people, one mole of people, is divided by the world population, you get a number like this. That is 75 trillion, or we can call it 75,000 billion. So what we did was, we divided one mole of people by the world population, and we got this value, 75,000 billion. The meaning is, one mole of people will live. Imagine this one. You have to imagine. One mole of people will live if there are 75,000 billion worlds with humans. 75,000 billion worlds like the earth. In each one, 8 billion of people are there. So one mole of people live in 75,000 billion worlds like earth. So you can understand what a big number it is. So that using it for macro objects is useless, since such numbers cannot be found. So we use mole to measure number of particles like atoms, molecules or ions. So one mole means 6.22 into 10 to the power 23 atoms, or ions or molecules. It's fair to use because that if you draw a dot like this, it contains millions of carbon atoms. So that means mole is a suitable unit to measure tiny particles in atomic scale. So 1 mole means Avogadro number of particles. The symbol of mole is MOL. When you write 1 mole, you can write like this: 8 moles. MOL is the unit for mole. So if we say 1 mole of carbon atoms, 1 mole of carbon atoms, meaning is Avogadro number of carbon atoms. One mole of carbon atoms. This number of carbon atoms. And if you say 1 mole of water molecules, the meaning is there are 6 into 6.022 into 10 to the power 23 water molecules. Water molecules. A large number of molecules. Now you can see that in one water molecule, two hydrogen and one oxygen atom. Two hydrogen atoms, one oxygen atom. In one water molecule, hydrogen atoms, two. Oxygen atoms, one. In 100 H2O molecules, you will have 200 hydrogen atoms and 100 oxygen atoms. So in one water molecule, two hydrogen atoms and one oxygen atom. In 100 water molecules, 200 hydrogen atoms and 100 oxygen atoms. So if 1 mole of H2O molecules are considered, hydrogen there will be 2 moles, oxygen there will be 1 mole. 2 moles means 2 into Avogadro number. So in 1 mole of water, 2 into Avogadro number of hydrogen atoms are there, and 1 mole of oxygen atoms are there. If you are asked how many atoms are there in 1 mole of water molecules, atoms, there are 3 moles of atoms in 1 mole of water molecules. So 3 moles means 3 into Avogadro number. molar mass. When you take 1 mole of substance, the mass of that 1 mole is called the molar mass. Now, as an example, mass of 1 mole of helium is 4 grams. Is 4 grams. So we can call molar mass of helium is 4 grams per mole. So molar mass of helium is 4 grams per mole. 1 mole is 4 grams. So we call it 4 grams per mole. Mass of 1 mole of magnesium is 24 grams. So we can call molar mass of magnesium is 24 grams per mole. So the unit of molar mass is grams per mole. To indicate molar mass, we use the symbol capital M. Unit of molar mass is grams per mole. Now let's see how the molar mass is found. It's easy to find the molar mass. In the last lesson, we learnt about relative atomic mass and relative molecular mass. Relative atomic masses are not, they should not be memorized because they are given. Right? Even in the test exam, you will be given the relative atomic masses of the elements. But when it goes for compound, if it is covalent compound, relative molecular mass, we had to find it. And in last lesson, we learned how to find the relative molecular mass. And if it's ionic compound, we call it relative formula mass. And we know how to find it if the chemical formula is known. Now, if the given one is an element, it's very easy to find the molar mass. Now, as an example, some relative atomic masses I will write here. Oxygen 16, nitrogen 14, hydrogen 1. So finding molar mass of an element is very easy. We have to do like this. Molar mass of an element equals to this. Relative atomic mass in grams per mole. That's all. So, as an example, molar mass of oxygen. Molar mass of oxygen. Relative atomic mass is 16. So, the molar mass is 16 grams per mole. 16 grams per mole. Molar mass of nitrogen, M of nitrogen, is 14 grams per mole. Molar mass of hydrogen is 1 gram per mole. Molar mass of a compound is found in this way. Either relative molecular mass for a covalent compound or relative formula mass for a ionic compound should be expressed in grams per mole. Then it will be equal to the molar mass of that substance. As an example, we will take water. So we know that hydrogen is 1 relative atomic mass, oxygen is 16. So relative molecular mass of water will be 2 plus 16 is 18. Relative molecular mass of water is 18. So the molar mass of water is 18 grams per mole. 18 grams per mole. So finding finding the molar mass of any compound is easy if you know the formula and the relative atomic masses. You can find the relative molecular or relative formula mass and express it in grams per mole. That's all. So you'll get the molar mass. Relative atomic mass of carbon is 12. So that molar mass of carbon should be 12 grams per mole. If we consider this isotope of carbon, the molar mass is exactly 12 grams. So molar mass of carbon 12 isotope is 12 grams per mole. That means 1 mole of carbon 12 atoms is in 12 grams of carbon. 1 mole of carbon atoms are there in 12 grams. 1 mole means the Avogadro number. So that we can say that in 12 grams of carbon 12 atoms, 6.022 into 10 to the power 23 carbon atoms are there. Using that concept, we can define the mole. So we can say 1 mole is the exact number of particles in 12 grams of carbon 12 atoms. Right? Means the number of carbon atoms in 12 grams of carbon is 1 mole. So that's how we define the mole. Here we use these letters for molar mass capital M, number of moles simple n, and mass of the substance is taken as M. Then we can build up a relationship like this. Number of moles equals the given mass divided by the molar mass. Number of moles, number of moles, the mass and the mole mass. Now as an example, find number of moles of water in 54 grams of water. Find number of moles of water in 54 grams of water. We know that relative molecular mass of water is 18. So the molar mass of water is 18 grams per mole. So we can use this. The mass is 54 grams. The molar mass is 18 grams per mole. So number of moles equals mass is 54 grams. The molar mass of water is 18 grams per mole. So that grams cancelled. 18 into 3 is 54. So the answer is 3 per mole to the power minus 1. When it comes up to the when it comes up, it becomes small. So 3 moles of water are there in 54 grams of water. The formula can be changed, interchanged, and can be used. Now here, if we know the mass and molar mass, we can find the number of moles. So if mass is transposed as equals number of moles into molar mass. So if we know the number of moles and molar mass, we can find the mass. And in the other way, we transpose m, n will come here. So molar mass equals mass divided by number of moles. So if we know the mass and number of moles, we can find the molar mass. So according to the question, we have to use the equation. So the main equation is this. You can transform it and do the calculations. N is for number of particles, capital N. Simple N is for the number of moles, and A is Avogadro number. So we know that in 1 mole, Avogadro number of particles are there. So number of particles in 1 mole is the Avogadro number. If it is 2 mole, you have to multiply it by 2. So that means it should be multiplied by the number of moles. So to find number of particles, the number of moles should be multiplied by the Avogadro number. Avogadro number actually it's written in this way: 23 per mole. In 1 mole, this number is there. As an example, in 3 moles of substance, there will be this number of particles. 3 mole into 6.022 into 10 to the power 23 per mole. So mole per mole cancel, and you get answer like this. So you can keep it in that way or can be simplified. Now we'll look at this question. If you are told to find the number of moles of ammonia in 51 grams of ammonia, 51 grams of ammonia, nitrogen is 14, hydrogen is 1, relative atomic masses are given. So we have to find the number of moles of ammonia. So that is n number of moles. So we have to find the molar mass, because mass should be divided by the molar mass. Now we can find the relative molecular mass of ammonia. Nitrogen 14, hydrogen 1, such 3 atoms are there. So 17 is the relative molecular mass of ammonia. So molar mass of ammonia is 17 grams per mole. 17 grams per mole. Okay, right, then we can substitute it here. The mass given is 51 grams and the molar mass is 17 grams per mole. So that is 3 moles. So there are 3 moles of ammonia. So if we are told to find the number of ammonia molecules, how can we find it? Now here we found number of moles of ammonia. So number of moles of ammonia, number of moles of ammonia is 3 mole. So how do we find the number of ammonia molecules? Now you know in 1 mole of ammonia there is Avogadro number. So number of molecules equals number of moles into Avogadro number. Since there are 3 moles, that should be 3 into Avogadro number. So it's 3 into 6 is 3 into 2, 6, 6, 0, 18 into 10 to the power 23. So simplified, we can write it as into 10 to the power 24. So there are such number of ammonia molecules. Now if we are told to find the number of hydrogen atoms there, now you can see in 1 molecule of ammonia 3 hydrogen atoms are there. Because of that, in this number of molecules of ammonia, 3 into that number of hydrogen atoms are there. So using the chemical formula, that's how we find those things.